continue to talk about the cost of Tesla leasing versus buying. In my previous videos, I have made a series of comparison of the total cost in terms of leasing versus buying with a loan. One of the key points that I made is that with Tesla lease, there is a benefit of a certainty. In other words, you know what you are going to pay in terms of total cost at the end of the lease. Whereas if you buy a car, you're not certain because you don't know exactly how much you're going to get when you sell the car, let's say at the end of the 3-year period for comparison. Now, in this video, I'm actually going to tell you a downside of leasing a car, not only Tesla, any car. And if you see my lease here, and there is a limit on mileage, how much I can drive. Here, you cannot exceed 30,000 miles. If you do, you pay 25 cents per mile. That's pretty steep. If you think about it, you go over, say, 10,000 miles, that will cost you an extra $2,500. So, this gets you nervous, right? And, you're not sure if or how much you're going to go over. Now, today I'm going to, again, using Excel spreadsheet to illustrate an interesting statistical aspect of such mileage behavior. So here's what it's a very simple setup. Say here the mileage limit in the 3 years is 30,000. Now, if you divide by the lease period of 36 months, you get 833 miles per month. Okay, now you look at your own driving behavior. For example, you say, oh, I drive, let's say 30 or 20 miles a day, and there's 30 days in a month, so on average I probably drive 600 miles a month. However, there's some variation, right? Sometimes I drive less, for example on weekends, or actually on other weekends I drive more. So let's just say it's probably some kind of a statistical distribution, random, with mean of 600 and a standard deviation of 200. Okay, let's say normal, but it doesn't really have to be normal. But for simulation purposes, let's say it is normally distributed. Now, we're going to do two comparisons. One is that if this is my monthly behavior, what's the chance I'm going over my monthly allotment, which is 833 miles. And then we're going to simulate over all the 36 months and add them up and look at the probability of going over 30,000 miles. And you will see there's a big difference here. So let's first do the monthly driving simulation. It's very simple. You just generate a random seed and plug in the mean and the standard deviation. So as you can see here, I did 10,000 runs, and this is my monthly driving simulation. And as you can see here, I say if in the monthly, say, simulation or realization of the simulation, if I go over this limit, I count as a 1. At the end of the day, I just count how many times did I go over, and then divided by this 10,000 runs. This gives me the probability or the chance of going over 833 months. So you can see that roughly there's a 12% chance I might go over. So this would get you pretty nervous. Are you asking yourself, or am I asking myself, at the end of 36 months, there's a 12% chance I'm gonna go over? Well, it turns out the answer is negative. So if you simulate out every month, I have months 1 to all the way to 36, and then you add them up. This is my total miles in 3-year period, and then you count how many times you go over the 30,000 mile limit. It turns out, I calculated here for you, it's almost 0%. You're almost guaranteed you will never go over. Now, of course, there's some strong assumption. Again, every month you follow a certain distribution, and moreover, it is independent month over month. Okay, in other words, this month's behavior doesn't tell you anything about how much or little you drive next month. Okay, so this is the assumption here. So how to reconcile the differences? Well, it actually there's a deeper statistical theory behind it. It says, I copy here, and there's one of the many references here. If your, say, monthly driving is a random variable, okay, and suppose its mean is mu and the standard deviation is sigma, then if you repeat it as a sample from the same distribution, in other words, month in and month out, your behavior doesn't change, follow the same distribution, then n is the number of months. So this summation of your monthly mileage tend to be normally distributed of a normal with mean of 36 times your average, but look at the standard deviation. The standard deviation is actually square root of n. In other words, 36 square root of that is 6 times your monthly standard deviation. In other words, even if your mean is 36 times of that, your standard deviation does not increase proportionally. In fact, it only increases square root of 36 6 times. So in other words, as you drive month in, month out, your total mileage actually have a smaller standard deviation. It becomes more and more concentrated around the mean. So that's good news for us. In other words, the variation kind of smooths itself out as you go on and on. Okay, so if you, in a particular month, what's the key takeaway? Well, the key takeaway is that if you go over or under in a particular month, you shouldn't worry too much, because over time, as long as your mean is not very high, you should be within the long-term limit. So I guess it is good news again after all. But again, I want to caution you that there's a strong assumption. For example, you need to estimate the mean and the standard deviation, and that the monthly data is independent. And that's it for today. I hope this is useful to you. See you next time.